Okay, welcome to the introduction to factoring or factorization. We're going to go over a few bits of language in this lesson before we can get into the actual idea of factoring. And the first concept to recall, this is from way back when, I don't even know when you might have learned this, is the idea of a least common multiple. Maybe that's bad language. Least meaning the smallest, common meaning that it is common to both or the same for both or even three numbers or four numbers. And multiple, what is a multiple? A multiple is a number that you can divide into. So if we look at this definition, the least common multiple, the LCM of two or more numbers, is the least, maybe I like the word smallest better, the smallest number that is divisible by each number. Okay, in other words, we have to pick some number here that each of these numbers can divide into evenly. Okay, and there are several strategies for this, but I think, now that you're in grade 10, probably the most useful method would be to just start listing factors, the multiples of each number. So for example, let's pick the easiest one here, 30. If I multiply 30 by 1, I get 30. If I multiply it by 2, I get 60. Multiply it by 3, and so on. You can see these are what we call multiples of 30. Okay, and what we're going to be looking for is what's the least common multiple. In other words, it will be common to all three of these. So let's keep going here, and you'd say, hey, look at, there's common multiple. 60, that would be the least common multiple between 20 and 30. Well, let's see if that works for 18. Well, 18 times 2 would be 36, times 3 would be 54, times 4 would be 72. Well, you can see here that 60 is not going to work now. It's not going to be common for all of them. So we're going to keep going here. Oh, 90, that's the same. So let's go back to 20. 90 is not going to work. So you can see we're going to need to go here until we find something that is common again. All right, 120 is common between these two. Let's see if it works for 18. Okay, and I'm going to keep adding 18 here. Oh, that's not working. 180. That's going to work. I bet you that works for 20 as well. Yeah, it does. So now you can see what is the least common multiple. It's 180. 180 is the least common multiple for those three numbers. Okay, take a second here and see if you can do these three. All right, what is the least common multiple for these three numbers? All right, now you've had a chance to do it. And you're going to say to yourself, wow, that's way harder than those three numbers. You're right, it is. But it doesn't mean it's impossible, right? Hard is not impossible. Hard just means it's going to take a little bit more effort. So 28, 56, let's keep adding 28 again. 84, add 28 again. Get 112, add it again. And keep adding it here. Okay, I'm going to stop there and see if that works for me. 84 does. Well, I can see that doesn't work for 63. 180, 189. Oh, well, that's a little harder. Let's add 63 to this, and you get 2, 5, 2. Okay, that's a pretty big number already. Let's see if that works for 28. So we'd have 204, 224, 252. This looks promising. Let's add 42. 126. 168. Lots in common here, just not common to all three. Okay, 210, and there it is, 252. There's our least common multiple. Now, I got to be honest with you guys, you're not going to see a lot of questions like this even in your homework, or definitely not your test. This is not really an outcome for grade 10. It's the language that's more important, the idea of what is a multiple. Okay, so let's go to the next skill here. Recall prime factorization. To determine the prime factorization of a number, write it as a product of its prime factors. Do you guys remember what the definition of a prime number is? Okay, let's go over here and make sure we know what this is. What is a prime number? A prime number is a number that only has two factors. Only two. And they are 1 and itself. Okay, so let's think of a few prime numbers. Is 1 a prime number? No, because it only has one factor, 1 times 1. Okay, so what's the first prime number? 2. The only factors 2 has are 2 and 1. 3. 3 is prime. The only factors 3 has are 3 and 1. How about 4? Is 4 prime? No, it has the factors 1 and 4, but also 2. So 4 is not prime. 5 is, though. It only has the factors 1 and 5. 6, no good. 7, yes. 8, no. 9, no. 10, no. 11. Okay, and if you think about some of these numbers, you can see that the only factors they have are 1 and itself. Now after 19, it becomes a little fewer and far between. I think 23, not 24, not 25, not 26, not 27, not 28, 29, etc. So that you have an idea what the prime numbers are. You probably won't ever need these bigger ones. Okay, so what we're supposed to do is write a number in terms of its prime factors. Okay, and it says use a factor tree. So let's start with this number, and we're going to draw a tree here. Give me any two factors of 3,300. Well, the easiest two would be 33 times 100. Okay, now we're supposed to write this as a product of prime factors. Are those two numbers prime? No, they are not, because 33 has factors of 3 and 11, and 100 has factors of 10 and 10. Are those all prime numbers? Well, 3 and 11 are, but 10 is not. So we need to keep going here. We're going to have 3 times 11, and now 10 can be written as 2 times 5, and 10 can again be written as 2 times 5. And if you look at those numbers, those are all prime numbers. So what I can do is I can write 3,300 as a product of all these prime factors. 2 times 2 times 3 times 5 times 5 times 11. That's prime factorization. Okay? I'll give you a couple minutes to try this one. See if you can factor that in prime numbers. Now, I'll give you a quick hint. That's a lot harder than 3,300 to pick the first factor. So my advice is, since you see that it's an even number, just start with 2. I know 2 goes into there. How many times? Okay. So 2 is prime. That's good. Is this prime? I don't know. So I've got to do a process of elimination here. First of all, can it be divisible by 2? No. Can it be divisible by 3? Well, you guys know the rule to figure out how to divide by 3? If it's divisible by 3? If you add up these numbers, 1 plus 3 plus 2 plus 3, you get 9. If 3 goes into this number, it's divisible by 3. So that means I can divide 1,323 by 3. Okay, so let's see how many times it goes in. 3 will go into here 441 times. All right, and if you're saying, hey, this is hard, by the way, I should tell you right now, this test is no calculators. So how do I divide this? Well, 3 does not go into 1. It goes into 13 4 times. And then 3 goes into 12 4 times. And then 3 goes into 3 once. Okay? All right. Let's keep going. So the question now is 441 prime? Interesting. Let's go through the numbers again. Is it divisible by 2? No, it's not. Is it divisible by 3? 4 plus 4 plus 1 is 9, so yes, it's divisible by 3. Okay, and 3 will go into there 147 times. Okay, continue. Is 147 prime? Well, 2 does not go into it. Does 3? Well, 1 plus 4 is 5 plus 7, that's 12. Yes, 3 again will go into 147. It will go in 49 times. And now you should say, hey, 49 I recognize. Okay, so I can write 2,646 as 2 times 3 times 3 times 3 times 7 times 7. All right. So that's prime factorization. Now, next part of this lesson is greatest common factor. Okay, the greatest common factor of 2 or more numbers is the greatest factor that the numbers have in common. Okay? So, I'm going to show you how to do this in 2 ways. The first one, and I think most of you, when you look at those 2 numbers, can tell me pretty quickly what the biggest factor is. Okay? And I'm going to write this out. I don't think you would need to do this, but can you write out the factors of 16? Well, there is 1 and 16, there's 2 and 8, and there's 4 and 4. How about 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6. All of those numbers go into 24 evenly. What's the greatest common factor? What's the biggest number that goes into both? 8. I think most of you probably could see that right off the bat, that 8 is the biggest number that goes into both. Now for 72 and 54, maybe that's a little harder. Okay, so I'm going to show you a couple of ways to do this. The first way would be to do this method. Just start listing the factors. I think that's a great strategy. Okay, here's another strategy, and that's to use prime factorization. If I take 72, I know this is 8 times 9. All right, and if I continue to factor this, I know that 8 is 2 times 4, or 2 times 2 times 2. And I know that 9 is 3 times 3. Those are the prime factors of 72. Let's try 54. What are the prime factors of 54? Well, 54 is 6 times 9. And 6 is 2 times 3. And 9 is 3 times 3. So what I'm going to do now is look to see what's in common. Can you see there is a 3 in common? And there is another 3 in common. And there is a 2 in common. That's the only numbers they have in common. Well, what is 2 times 3 times 3? This is 18. So 18 is the greatest common factor. Okay, and the question you're asking yourself is, what is in common? After you've prime factored it. So decide what works for you, what is the best strategy. They're both fine with me. Okay? All right, I'm going to stop there, and I will continue on the next lesson.